Hello. OK. So imagine you have some great piece of code. Maybe a new style of programming, like reactive programming, or promises, or results. Or maybe it's just a wrapper around an existing API. So it could be something like address book or keychain, which just has a not so great C API that you just want to make more Swifty. And so you have this great code, and you want to share it to the world. After all, it could benefit others, or your fellow engineers. It could save them hours or even days of effort. Where do you start? What's the best way to do this? Well, pretty much there's only one answer. That's to create a library. And so you create a new project, and you put your code in it. But that's just the start, because you'll want this code to be widely accessible. So you want to run it on multiple platforms, tvOS, watchOS, iOS, OS X. And with Swift being open source, you want it also to run on Linux. Then you want it easy to integrate with a bunch of you want to make it easy for developers to integrate your library. So you'll have to make it easy for developers to install your library the way they like to. So that means they'll have to use CocoaPods, Carthage, or the Swift package manager, or sometimes even manually via Xcode subprojects. There are still quite a few developers that like to do that. It's interesting. Next, you'll probably receive contributions from others. So you'll want to ensure some level of quality for your library. Usually this is through tests. And you want to run these tests frequently and very often to reduce the chances of introducing regressions or breaking things in your library. And then finally, you need to manage releases. You need to publish to all these package managers that you support, across all these platforms you support, in a consistent manner. And while describing to developers that are using your library, when is it appropriate for them to upgrade? So that's actually a lot of work. That's a lot of work around the core, which is your code. There's a lot of work that is not actually what you're trying to distribute as part of your library. And it's really just all the infrastructure around having a library started to get your library to as many developers as possible, to make it a great user experience. And so that's what this talk is really about. This isn't about the awesome piece of code you have that you're ready to share, because it's already awesome. I don't need to do anything for that. It's really about having the infrastructure around your code to make it a painless library to use and be a joy for other developers to integrate with. And Swift is a great programming language, but having more third-party libraries available in the ecosystem is great for everyone. A developer today could accomplish way more than a developer a few decades ago. And that's all because we can build upon the work that's been done in the past. So let's go build the Swift library. It's easier to follow through an example, because then all the concrete demonstrations and snippets that I'll use will make a lot more sense. So as all good libraries, you need a really good name. So I'm proud to announce Snorlax. Da, da, da. This library has one feature, and only one feature. It is to sleep for a random amount of time. This library, therefore, only has one function, rest. It'll just sleep for a random amount of time. And look, I've even added documentation. So this is ready to be used and distributed for everyone. I think it's production ready. And like all good libraries, we have a test. In this case, I have just an asynchronous test. There's many different ways and strategies you could write tests for this. But for the sake of this library, we're just going to use an asynchronous test. And it doesn't really matter about the test itself, because what's more important is that this test will change over time as we support more platforms. So that's Snorlax. That's all the code that this library provides. Obviously, your code would be more awesome than this. But let's get started. So we have this code, and we're going to put in a new Xcode iOS framework. So there's, from the bare minimum that Xcode provides, there's several build configuration settings we need to change so that it will be smooth when developers that use your library will integrate with. And so the series of steps I'm going to show will apply to every framework you make in Xcode, even though for this case, I'm just doing it for iOS. So first, we're going to make the scheme shared. This will allow us to run tests for the continuous integration in the command line. And we'll ensure that those build configurations on how to run those tests is synchronized across anyone that's working on this library. Next, snorlax is actually great for extensions. So there's a little checkbox on the bottom over here that's allow API extensions only that we're going to check. So this will allow it so that our library can be integrated with extensions such as widgets or watch apps. And so if you can't see it down there, maybe it's a little bit bigger. So this is just in the general tab of the build setting. You just check that and you're all set. Finally, we'll have to rename this one build setting, which is product module name, or you might just see it as module name. We want it for all the frameworks to be unified under one name so that when a developer uses our library and they call import, it's all uniform. So by default, it'll give it whatever name it has. And if you have other projects, other platforms, it might postfix some operating system name. You just want to change it to be uniform so that all your developers can just say import. That was it. We got our iOS framework. Woohoo! We could just expand it to all the other platforms, but in an effort of saving time and not repeating myself, you just do the same thing for all the other platforms. It's worth noting that watchOS does not have test bundles, so you have to be a little bit more careful to make sure that you integrate it properly, that you didn't forget a source file. So next, testing, more specifically continuous integration. We want to set up our continuous integration service with our library so that we get great feedback of when something breaks when we're making changes to our library. For open source, since this is primarily a library that you want to share and have contributions, there's really only one choice. As JP mentioned, that's Travis. And it's useful because it supports a bunch of different features that a lot of other CI systems don't have. You could emulate it with Jenkins, but it's a lot more work. So it has a whole bunch of extra features, specifically like if you want to target Xcode betas, you can do that. Or if you want to have multi-OS builds or different versions of SDKs to run on with matrix builds, you could do that. And it's managed, so I don't have to run the server, which is great. So for Travis, you just need one file, which is a travis.yaml file. And for just Apple platforms, this is really all you need. You just need 3 lines that describes exactly how to run. So I'm running on Xcode 7.2. I'm using Objective-C, lie, it's a Swift, but it configures, Travis will configure everything correctly. And then I call out to a script to run the test. And this, I prefer to run a script because then if I need to emulate it locally, I can just easily run just the test script instead of having to kind of copy paste the commands that I'm telling Travis to run. And this test script isn't that difficult at all. It looks like a lot, but it's mostly just running Xcode build test for each of the supported platforms. So watchOS doesn't have any tests. So it's really just OS X, iOS, and tvOS. And then there's a shell script command to make it fail early. Not that complicated. And with that, we have Travis integration. So when someone sends a pull request to any project that has this, Travis will automatically build and run the tests on the platform. So that's super convenient for when you're just doing development. And I like to merge pull requests via my phone, so having another machine run tests is super nice. Next. OK, so at this point, Snorlax can be used only if the developer integrates it manually. If they know how to integrate Snorlax as a sub-project in their app. So we should expand it to more package managers. And there's currently 3 popular package managers. Well, 1 upcoming. CocoaPods, Carthage, and the Swift package manager. So let's look at the most popular one first, CocoaPods. It's the easiest to use, because if you're not very familiar with how Xcode builds projects, CocoaPods provides a hassle-free way of installing third-party dependencies. And the way it does it is that in CocoaPods, you define a pod spec file, which is work that we have to do as library maintainers to specify what's the proper way to set up and configure the library. To get started, we just run one command, and CocoaPods actually does reasonable defaults. So this is pretty much all you need to do to create the file. And then you just need to tweak some of the file settings, some of the defaults, like what does this library do? And what's the version of this library? What's the name of this library? But more importantly, it also lists dependencies or any kind of build configuration that you need. So in this case, we need to list dependencies on foundation. So in the pod spec, the only change really to add is add foundation. If you had other third-party dependencies, you would have to add it in the pod file, but snorlax doesn't require any of that, so we can move along. Next, Carthage. Carthage requires more familiarity with how Xcode builds projects. So on the end user's perspective, they have to do the actual final integration into their project. So it will handle building dependencies and figuring out which versions it needs for their project. But in the end, it is the developer's job to integrate it into their application. It's actually a really good alternative if you're used to just manually adding Xcode projects, because it kind of automates picking the versions for you. And so really, there's not much to do with Carthage. You just need to run one command which will verify if Carthage can actually build your project. And so you could just run this. The no skip current flag indicates that it should just always build it instead of trying to be smart and saying, hey, I'm done. Don't need to build it. I already built it before. So if we had dependencies, though, we would actually need to specify the Carthage cart file in our repository. But since Snorlax doesn't have any of that, we don't need to do anything. Sweet. Next, Swift Package Manager. JP talked about this, but it's actually a lot more work than the other two package managers. And it's still relatively new and ever evolving. In fact, I updated it like yesterday. So it's always changing. What's interesting, though, is that Swift Package Manager, as JP mentioned, is the only one that supports Linux. So we'll have to also support Linux in conjunction of supporting Swift Package Manager. So the way Swift Package Manager works is that it has a package Swift file, kind of like CocoaPods, and you could define just what targets you have. By default, it will imply one target, which is Snorlax, and that's really all you need. Because in the new Swift snapshots, it can infer the primary target you want to build and your tests, and we'll see how it works with the project structure. It's also worth noting, if we have any dependencies, we also, like CocoaPods, have to list it in here, but we don't. So Snorlax is a very basic project. It has two files, and the Swift Package Manager requires a specific layout in order to infer how to build your project. So we have our package Swift file under our Snorlax directory, and we're going to move our source code into the sources folder underneath Snorlax, which is the target name that is defined in the project Swift file. And so that's where I'm just going to put all my source code. The same thing applies to tests. So I have one test file, and I'm going to put it under equivalent one under the test folder. And the Snorlax namespace, the name comes exactly from the package Swift again. Finally, for Linux, we need this extra Linux main file, which tells the Swift Package Manager how to run tests in Linux, because it doesn't have the Objective-C runtime to kind of do the introspection to figure out where are the tests. So let's look at this main file. It's actually pretty simple. We import xctest, and we just call xctest main. And we just list all the xctest case classes we have in the tests. I only have one, so we're only going to run just one. Pretty straightforward. It's also worth noting that Linux main should only be in your project and not be part of your Xcode project. Xcode does not want to know about this file at all, so you just make sure you don't have it. So next, we have to update our tests. First, xctest doesn't support async for Linux, so we got to remove that. And so I converted it to not be async. And second part is that there's extra code that we need to add to support the fact that Linux xctest does not support reflection, because you can't use the Objective-C runtime. So we have to manually list out all our tests by inheriting the xctest case provider and specifying it there. But there's a problem. Because xctest case provider actually is only available on Linux Swift. So you actually have to do some polyfill, which is what this example is doing, to define xctest case provider for Apple's platforms so that you don't get a compile error or have to if else your entire Xe test case. And so usually you just put this Xe test case provider definition somewhere, and then all your other tests can just work their merry ways. So with all that, we can actually build our code. We could run Swift build, which will build our library and our test bundle. And then we could run Swift test to actually run the test. So, they're all that work. But wait, there's still some more problems. Swift Linux isn't stable, so the versions always change. And there's been a whole bunch of new versions released every week. And keeping up to date is extra work. And it'd be nice if we optimize this workflow. So this means that we have to synchronize the version between developers that are working on the library, as well as our continuous integration library. So it's a lot of hassle just constantly be updating it and coordinating with other contributors saying this is the version that we're using. Instead, I would recommend using a library from Kyle Fuller called SwiftEnv. And if you're familiar with Ruby or Python's RBEnv and PyEnv, this is the equivalent one just for Swift. And it basically allows you to use a specific version of Swift for a project. And so with SwiftEnv, we will install the latest snapshot of Swift. And we'll say local, use that version in the current working directory that we're using for this version of Swift. And with that, we could just run the regular Swift commands, and it'll automatically use the right Swift executable. Our CI is going to change slightly. We now have to use the build matrix that we're using, I was talking about before. And so we're going to target OS X and Linux, and either using Xcode to build the test suite or the Swift package manager. And so there's this one line of install at the very bottom, which is abbreviated. There's more references later, which installs SwiftEnv in a one-liner. And then I just run tests with the environment variable type, which the test script is smart enough to know that if it sees SPM, the string, it just runs the Swift build test versus all the Xe test ones that I listed before. And so in Travis, now we have 3 builds for every build or every commit. And so that's super nice to see which platform is actually failing. So if someone makes a change, they will see if Linux will fail, or OS X will fail, or OS X specifically package manager will fail. So that is super nice. And I think we're ready, almost, to create a release. We're ready to release this great new library. And so we have everything configured, and we just need to release it with a version. But what do we need to use? How do we set version numbers? You see all these version numbers? What do they mean? Turns out it's very common for for many libraries, and in fact, it's encoded in all the package managers to use semantic versioning. So there's the first, least most significant number is the patch version, which is used to indicate if there's only bug fixes. So if the patch version increments, only bug fixes have been applied to the library, and no breaking changes or new features have been added. If you update the minor version, you're indicating to developers that new features have been added and bug fixes may have occurred, but no breaking changes have been made to the library. Whereas if you increment the major version, all bets are off. Everything could have changed, everything could have broke, all new features could have been there, and all the bugs were fixed, hopefully. And so you have to choose specifically which version number that corresponds with what changes that we're making. In this case, this is the first version, so you could just set whatever version number you want. So that's fine by me. And with that, we can start actually going through the process of releasing each version. So, oh yeah, if you want more information about semantic versioning, there's actually a nice page that just explains in great detail how to do semantic versioning if you're ever confused about how that works. So now we can actually go through kind of the routine of creating an actual release for our library. And most of it is pretty straightforward. There's some explanation of like why you need to do this. Most of it's to support CocoaPods. So in the beginning, we're going to find all the version numbers that we specify in documentation or the pod spec, because the pod spec will contain the version number, and we'll just set it to this new version that we want. We'll commit it, and then we'll push it to GitHub or whatever source control you use. We'll then tag the new version with the particular version number that we have, And this is useful for Carthage and the Swift package manager, because they look at tags to determine what version to pull in as a library. And they're following semantic versioning, so keep that in mind. Finally, make sure you push it so that those package managers can see it when they look at the repository. And then after that, you need to push the pod spec to CocoaPod's trunk. And this will tell CocoaPods that a new version of your library has been released. And so CocoaPod users can then use the new version that you've released. Finally, if you want to add some extra sparkle, you can create a release on GitHub. Just makes it look bigger and better in GitHub. And then just announce it to the world. Hey, I got this new library. It allows me to sleep for a random amount of time. I actually have the whole library in all its glory on GitHub. It's Snorlax. It's the world's boring code, but it actually has all the infrastructure around setting up the library, the CocoaPods, updating for Swift package manager. I advise you to look at actually the commit history. The commit history actually is broken down by each of the steps that I've done to support all the different platforms. Also, there's supplementary to the supplementary material. There is Snorlax samples, which is examples that integrate Snorlax as a dependency. So you could see how it works under iOS and under Carthage, CocoaPods, and Swift package manager. And so, with that, thanks. So I have 5 minutes for questions. Yeah.
So on GitHub, so I believe V was added for the version. So is it better to add this V or not? I usually don't have this V on it, so I was wondering whether I should include the letter V or not.
OK. The question is, should I add the V or not to your version tags? The ever questions of life, like tabs and spaces. I always put the V because it's easier to then filter by the tag version. So if you have other tags, say you're targeting a different branch for Swift, like an older version of Swift or older releases, or having any other kind of uses for tags, like for deployments, it's better to have some way to categorize your tags. So that's why I prefer the V. If you feel like your library won't ever need that, then that's fine.
Hi. Sorry. Is there anything in particular you would recommend if my library depends on another library that's, say, not Foundation?
Yes, I forgot to mention that. So actually, in the Snorlax repository, it actually includes examples of pulling in other dependencies as part of the library. Thank you for asking that question. There is extra work you need to do, but it's a little bit more difficult with the Swift package manager because just a lot of libraries just don't support it yet. But for Carthage and CocoaPods, you could perfectly do that. I will mention, though, that it's not recommended to use CocoaPods to integrate your library, because then you make a dependency on CocoaPods as a requirement for anyone using your library. So you should make sure that if you're integrating third-party libraries, you should use either Carthage or Git submodules and doing it manually, instead of doing it through CocoaPods, because CocoaPods changes your configuration so that it basically depends on it.
Hey, thanks for the great talk. Would you have any particular recommendations if you were doing something like for just like an internal library within a company, say, that you didn't want the source to be public? Would you do like private CocoaPod, or like how would you handle that?
Yeah, that's a great question. It depends entirely on kind of what's the current ecosystem that your company is using. So if your company is using exclusively CocoaPods, then yes, make a private pod spec, private specs repo, and store your dependencies there. But if you're just having like some internal GitHub enterprise, you just use Carthage or Git submodules instead. And you don't have to use all the examples. This is like a complete coverage of all possibilities of all platforms, right? Not every library is going to have to support every platform that Swift is on, because it might be like a wraparound and Objective-C API. In that case, then maybe you don't need to support like Linux. So it's perfectly OK to take bits and pieces of what I said in this talk to cater to what the circumstances your library is in. Yep. Thank you very much.